Welcome, everybody. My name is Adam Hems. I'm the leader of the Houston Azure User Group. Warm welcome to those of you in person and those of you online. For those of you in person, the room is muted. Is now live. And so FYI, if you would like a private conversation at the back, you want to exchange some private details with somebody, quiet little chat back there, notice that the mics can hear you and it's being recorded. So FYI, if you want a private conversation, step outside of the room because the mics can hear all. And so that also means that when there's any questions that the folks online can hear you as well, but just FYI, okay? All right, all good. A warm welcome then. So like I say, I'm the leader of the Houston Azure User Group. My day job is as a cloud solution architect at Microsoft, and as part of this is one of my hobbies, with the help of my colleague and friend Kim and frequent presenter in the front there. You met her son Sean, who helped log everyone in. I cannot do this alone, very much a team effort. And the food tonight, Microsoft is helping out with the food tonight. So I have an ask for you all. Do you see the barcode up here or the link? Would you mind busting out your cell phones and just having just waving your cameras and click the link on there? That would really just help from a marketing perspective, because the Microsoft folks are paying for our pizza tonight, which, you know, personally I like it. Pizza good for everyone? Those of you in person, yeah, it's all good. Right. I've so far managed to find various sponsors of our meetup, and I like it that way. That makes it easier for everybody. Me in particular. Thank you, Ray. Speaking of which, Ray reminds me that there's also Wi-Fi available here. I put it on the board at the end for those of you in person, and that's specifically for Ray, frequent visitor right there, who always wants Wi-Fi. That's why the Wi-Fi password this month is for Ray. That's why. That's Ray right there. It's really nice to see some regular folks like Ray, and many of you have come back. Who's new? I know I've met some of you of the group here. Who are the noobs? I can't. Noobs. A warm welcome. A warm welcome. And William back there. Okay, a warm welcome.
Actually, it's a return.
A return?
Yeah, I've been gone for like a couple of years.
Okay.
I was in Fourth Ward.
I
drove down to meet my family, and there's some time. I'm here.
Okay, welcome back. What is your name?
Caroline.
Caroline. Welcome, Caroline. Good to have you back. So for those of you online who are new, and for the recording, I see a couple of folks right here. The intent of this group, which I took over in 2016, is for learning, right? There's Microsoft, my employer, and other employers have had lots of marketing events during the day that we can all go to. Right, Bill? Bill, it's at the far end. Okay, Bill, thank you, Kim. Microsoft has lots of marketing events, and we can all, you know, those of us who find that interesting can go and do those during the day. And professionally, right, I work with individual companies and get to see their cloud journeys. I've been working with Azure since 2010 when it first came out. I was actually at the launch of Azure in 2010, and we're working full time with cloud since about 2012, 2013, doing nothing but cloud. AWS, I've had an account since 2007, and Azure since about 2012 to full time. And so I've seen a lot of cloud journeys, but what I haven't really been able to do as part of my professional career, my day job, as it were, is facilitate conversations between folks on the same cloud journey at different companies, at consultancies, at large companies, SaaS companies. Here in Houston, we've got healthcare, we've got financial services, we've got all kinds of companies, large and small. And the cloud journey that I've seen for most is the same basic journey. There's a lot of the same hurdles and things that encountered, and business problems vary, of course, based on industry, but the cloud journey, because the technology is the same, obviously, and therefore much of the journey. So there's not really an opportunity for folks to learn from one another during my day job. That just doesn't happen because NDAs and things like that. So that's why this community, that's why this, right? It's an opportunity for you to chat with one another, hopefully learn from one another, and share stories and gain experiences, network, grow. I've encouraged recruiters to come here and offer up positions. I encourage them to post positions on the meetup site, because that's also part of what we're trying to do here. It's a community thing, not a marketing or sales bit. So no sales. If you're here for a sales pitch, wrong place. There's no sales here. This is just about learning. If you're here to learn, you're in the right place. Okay, so with that, I'm presenting tonight. Did everyone? Please do me a favor. Did you all click on the little barcode thing right there? Really helps if you don't mind. Thank you. Appreciate it. Helps encourage sponsorship if we do that. So without further ado, tonight's topic then, DevSecOps. So something that I'm passionate around. I've worked with a lot of teams on this particular problem, and specifically around AKS, which is one of my favorite technologies, mostly out of all the Azure services that I've worked with. That one's one of my favorites, simply because it is brutally complicated. Is anyone familiar with Azure Kubernetes Service? There's one you know. Couple of folks grinning at the back there. Yeah, I know you guys know it. So it is brutally complicated. That's why it's one of my favorite solutions, because it's really hard to get right. Now there's lots of guidance, but the simple solutions, just deploy them and there you go. Not too much to it. But yeah, this one's the AKS, very complicated. I mean, really complicated. Although what's interesting is that if you go to the quick starts, right, on the documentation, seems really easy. Just a couple of commands, up it pops, done. And that doesn't take into account any of the security best practices that Microsoft recommend for that service. And that therein lies the problem, right? And that is one of the purposes of this presentation. There's no quick starts. Let me tell you, we're not going to have any quick starts at all in this presentation, because none of them are useful here at all. These are all about the best practices, really, for getting everything from getting the code the developer writes all the way onto one of those AKS clusters. And it will also include, as part of that, how to make sure that infrastructure was deployed correctly as well to start with. Like I said, not via a quick start, right? Deploy this infrastructure via a quick start, then it's not following any of our best practices. And there's a lot of steps in that way. In fact, I think I'm going to just jump on a little bit and show a picture. Oh, there it is. Okay, all right. We're going to come back to this. I jumped ahead. We're going to spend some time on this picture. Anyone recognize it? Anyone seen it before?
Yep.
It's in the documentation, not a secret, nothing proprietary right here. But we are going to basically go through this picture in a fair amount of detail, right? All the way from, on the far left, we have the developer right here. Can you see my little laser pointer thing? See my laser pointer? Yeah. So the developer all the way right here, writing their code in their tools through GitHub, through storing in Azure Container Registry, to AKS right here, and other services that attach onto it and talk to it. So this is all up in one picture, DevSecOps for AKS. So what we're going to spend some time doing is going through these various pieces. We'll come back to this picture, and also some demos, right? So that's, I could have had that picture up front, but I just wanted to jump ahead. I like pictures. We'll end on that picture, which will hopefully make more sense once we spend a little bit of time setting up the various pieces of that picture, all right? So first, and there's chatting to some of you and also folks online, not everyone necessarily knows what DevSecOps is, right? It's a buzzword, like so many. So just a couple of definitions to help those who are newer, because again, this is all about learning, right? What some of these terms mean, and then we'll get to how these fit into that picture that I was shown. So what is DevOps first? Not DevSecOps. This talk, we're talking about DevSecOps. So first of all, what is DevOps, right? Embedding IT operations in development and development in IT operations. So this is automating the writing of the code and the operations of the infrastructure that runs that code as a continuous circle, right? Rather than back in the day of things being thrown over, developers would throw things over the wall to the infrastructure people who would then have to install packages. And then when stuff broke, fetch logs and hand them back to the development teams in most hideously inefficient and siloed things. Many of you may remember it. It's just a horrendous time back in the day to much more efficient automated deployments using tools like agile processes and CI/CD, continuous integration. It's the CI, which means the continuous testing of the code, the development team write. CD, which is continuous deployment, so continuously via automation, putting new versions of the code the development teams write on the infrastructure. So in this case, the infrastructure is going to be AKS, along with all the logging and, of course, production monitoring that is necessary to know the health of both the infrastructure and the code when it's out in production. And then the benefits, really, of this is deliver software products more quickly, fewer errors, and with higher quality. So that's why we do this, right? In particular, quickly. That was the key thing. Any developers? I meant to ask. Any developers in the room today? Oh yeah, a few developers. Excellent. Welcome. I'm a developer. I slung code for about 10 years. No, maybe more than that. More than 10 years. Yeah, more than 10 years. Wrote a lot of code, and so all of it bug-free. But yeah, maybe not so much, but I was, of course, part of the whole DevOps cycle right from the earliest days, and seen those silos of yore and more moving towards more quick deployments of code via automation, which these days, with the help of the cloud, very, very highly automated. So it is the way of it these days, right? It is the way. This is how developers who are writing custom code for deployment on automated infrastructure in Azure. This is how it's done. DevSecOps is a slightly newer term, right? And actually, I'll segue here a little bit. So just sharing some of the reasons that this is important. There's a lot of things that I see as part of my day job when talking to customers that I can't really share for NDAs, things like that. But generally speaking, hand wave, right? What we have seen, what is the case, is that particularly in the cloud, we have all this infrastructure stood up to run the production workloads that the developers write, okay? And much of that you'd think would be, or at least is often thought of as being, from a security perspective, the weak spot, right? It's on the cloud now. It's not on premises, and so the fact that it's not on premises and it's now in the cloud, the infrastructure that runs the code, that's kind of the problem. And so that the thinking often goes is therefore the security weak spot. What has come evident is that actually really these days is not the weak spot. The weak spot, the easiest way to exfiltrate data on that production system to get it off of there isn't to hack into the front door of the infrastructure on the cloud. That is not the easiest approach. That is not these days, right? The easiest approach is to actually get hold of some credentials from the most junior part-time developer who is writing some code, who then deploys it via DevOps onto the infrastructure. Because if you have the credentials of the most junior, most part-time developer who then has access just to some source code that they're writing for this application, what happens then is that code gets built, it gets changed, maybe some additional pieces get put into that code, right? Nefarious pieces that appear innocent, pass all the unit tests, everything works, all the code runs, application performs as it should. And then via DevOps, via all these automated processes that make it really easy to get the code from the developer's workstation and then onto the production infrastructure, which is very secure. It's all locked down, it's protected, but that code has been placed on there by automation as part of DevOps, where that code then has access, because it has to the data that is of value to the bad actor, right? The code reads it as part of the application. So of course it has access to it because it needs to serve it up to the users and all those kind of things. But the fact that it had some additional, let's say, hidden payloads added to it by the compromised credentials of the developer, unbeknownst to anyone, and then it's placed on this production infrastructure, means that then the opportunity for that nefarious code in amongst all the valid code, it has the ability then, and we often see this, to exfiltrate that data to somewhere else where it is then misused for whatever reason, whatever bad reason. So that is by far the easiest way to get the data off of that secured infrastructure. Not coming in the front door, because the infrastructure remains secure, right? But it's through effectively leveraging the automation of DevOps and weakened credentials right at the beginning, achieved, however, in order to provide to threaten that data. That's kind of a problem, right? If that's the easy route and the developer's credentials or the developer themselves are then the most junior, most part-time, most contractor, most unimportant is the problem, then, okay, we need to actually secure the entire chain all the way from the developer to our already secured infrastructure. We don't need the infrastructure is good. It has been for a long time, not a problem. It's everything getting up to that infrastructure that we've seen is the problem. That's actually the weak spot now. All of a sudden, didn't used to be, but because the infrastructure is now very robust, it's the front door to the castle gates with the moat and everything else in front of it. It's just why go to all the effort of trying to go in the front door when you can sneak it in the back, right? So it's this DevSecOps is now the pattern for protecting the new back door, the weakness from the developer and the code that gets compromised and then placed on this very, very secure infrastructure. So that really is the genus of DevOps, integrating security practices from all the way from secure development lifecycle, which has been around a really long time. And secure development lifecycle is just writing secure code from the beginning. That's old. That's old. Been around a long time, have to assume those things. And that was about writing code that has fewer vulnerabilities in it. But the extra pieces that we add to this now are, okay, you've written secure code, great. How did it get from where you wrote it to where it's deployed on this secured infrastructure without, how do we know there were no problems along the way? And that is the essence of DevSecOps. Any questions or observations on that? Anyone surprised? No, lots of, yeah, I'll bet. yeah, that's the way of it. Kim has a question.
So typically in terms of, security, often most people would assume that network is the first layer of defense, but I would argue that identity become more of a security than a network.
Yep.
Because what Adam was saying, the infrastructure is so secure.
That's right. The infrastructure is locked down. The network is that's tight.
If you can hijack the identity, you're in.
Yep. Mm-hmm. Yes, the identity is the weak spot, or the human themselves in some cases, right?
You combine different practices because, identity is the area that provides you the keys to get into the environment. It's also necessary to combine with practices of segmenting things correctly. So even if you get compromised, your area of lateral of reach cannot be extended that much.
That's right.
Mostly between areas.
Yeah, defense in depth. So assume breach, exactly. Things like that. Minimizing the blast radius, given that nefarious code snuck in there somewhere. Yes, Andre.
Another factor is the avoiding the code execution in the server itself, because stealing credentials is one method, but we can steal cookies and other things, but avoid the code execution is another part, very important part of the process.
The actual execution of the code, once it's been deployed to the secured production environment. Yes. Yeah, that isn't something we're going to get too much into. So security of data at rest, for example, it's a given. That's just part of the infrastructure is secure. It's secured at rest. Okay. Secured in transit, we're not going to get into that because, all right, we know that. That's the secured infrastructure. That's also a given. Where we see less of a given that you mentioned, but is secure whilst in use. So there are some technologies as part of AKS that I'll mention. It's not as part of the content really here, that protect data whilst in use. So that is a way to protect data on a very, very hardened production platform that is not commonly done. You need specific infrastructure for that, and you need to code for it as well. That one's more rare. Not really part of DevSecOps necessarily, because again, that's the deployment of the code on the presumed secure infrastructure, right? Presumed secure, and like I say, generally speaking, like Ken was saying, the infrastructure these days is not the weak point, but it can be made stronger by protecting data whilst in use. I'll touch upon it when we get to the AKS infrastructure, which we'll touch upon it.
Is there any effect with the fact that people are accessing all this stuff remotely now, as opposed to on-site in a private network?
So I would say no, because that's about encryption of data in transit, right? So the fact that you're not physically close to it is these days less. Yeah, it's encrypted as all the way from wherever you are to where you're going. The problem is not on the tunnel you're using to access remotely. It's the identity you're using to access, to authenticate in order to get access to that. Because it might have been compromised, might not even be you, or you yourself might be actually a bad actor, hired as a junior developer at some company with the eventual intent to steal data from a production system for monetary gain. Who knows, right? That's the threat, not the connection used. Good question, though, Ray.
It's just harder to steal the information when you're in a building, on a private network, than it is when you're sitting at home accessing it through the internet.
Well, that certainly in the early days of the cloud, that used to be much more prevalent, right? The thought that we're safer on-prem. I can see the building. I can walk into it. I need a card to get into it. Only me can do it. I can physically see the servers, right? I know where they came from. I know the supply chain. I feel more comfortable with being able to see them, touch them, and the door and the locks on it. I feel better about that. That used to be the physical infrastructure security that was prevalent versus remote, distant, far away. If someone else owns it, data centers I can't see, data centers I can't have access to. That's was in the early days of the cloud, certainly a concern. These days, much less so. Those concerns are, I'm not saying people don't have them, but the risks of that are far, far lower. People still have those concerns, but people should have concerns about DevSecOps more, what we're talking about here, rather than the physical and the network and the things that you share, Ray. Not these days, not anymore. Okay, so quickly then, goals and benefits of DevSecOps: identify and mitigate security vulnerabilities earlier, wherever in the chain they might be, right? They might have been put in there inadvertently or deliberately, not necessarily by a developer as part of the development team, but perhaps by a developer on the team who is themselves a bad actor, right? And a developer who is themselves a bad actor, of course, in a modern process, wouldn't have access to production systems or production data at all. That's normal. Of course, they don't have access to that. But their code, once it's deployed to a production system, has to have access to that data, and therein lies the problem. We still need speed and agility, right? DevOps has increased the speed and agility with which we can update software. It's been a really good thing. We don't need security slowing that down. It's a problem. No one wants that. Security is always a problem for slowing stuff down. So we need to maintain speed and agility that DevOps gives, but by adding security to it. And it can't be incredibly expensive. We don't want to spend an enormous amount of money. We spend enough money on making sure our infrastructure is properly hardened, right? To making sure that that we've got security at rest, we've got encryption at rest, we've got encryption in transit, that least privilege, right? So that only the accounts that need access to read from the places that they need to have it, all of those kind of things. Go to a lot of time and effort to make sure that our infrastructure and everything related to it in production is robust, is secure. So we don't want to spend a lot of money on other things. So this needs to be as low cost as possible whilst maintaining speed. And then specifically, so a lot of that applies irrespective of the target infrastructure or the code you're writing in, right? Those are the patterns up there. If you're deploying to even virtual machines or web apps or Azure Functions or name the Azure service, there's a whole plethora of them where custom developed code can be deployed via DevOps and of course by DevSecOps. We're just going to focus on AKS because it has some particular components that are also areas of vulnerability, in fact, that we need to address. Kubernetes in general actually has the same one. So containerized apps to some extent have some additional vulnerabilities by the nature of the way in which the applications are built and deployed. So repeating what I just said, back to the picture that I showed at very, very briefly. Let's start walking through some of these components, and then I think I'm going to go a little deeper into some of the tools, services, features, extra things in Azure, some of which are on the diagram, many of which are not that are not covered up here. So let's start from the very first thing, Entra. I had to go find the Microsoft Entra icon. This is Azure AD, for those of you who've been around since 2010, which is when Azure Active Directory came out. It's been recently renamed Entra, and so Entra, previously known as Azure Active Directory, is the identity provider that protects all of these identities that was a concern right at the beginning, right? I was sharing that these identities, and Kim said the same thing, is the beginning, the source. If the identities in here are compromised, then there's a whole slew of other areas where compromise could still happen. So it starts there. You should have your identities in there. You should have multi-factor authentication enabled. There's a slew of security features in Entra that should be on. P2 licenses, there's a lot of Entra features that you should be using. That protects those identities. It has other features for doing things like checking to see if an identity logs in from one particular region and then within a short period of time logs in from a region a long distance away, right? That's a little suspicious, bit ropey. Credentials might be valid, even the multi-factor might pass, but if they log in from two different regions, that's questionable. And so you can have certain policies kick in and controls that can be enabled to maybe highlight, or at least highlight that risk. Hey, maybe this credential's been compromised because it's been used in a way that's a little suspicious, right? Things like that. Start with those. And that then is focused all around, again, our developer. So this is our developer, whomever he or she may be, writing custom code, which is going to end up on our Kubernetes cluster over here, eventually in production. The code that this person writes with the identity stored in Entra is going to be deployed to our Kubernetes service. And if we're using just straight DevOps, the path looks a lot like this. It's pretty similar. In fact, It's basically the same path, actually. A developer with an identity, they use their developer tooling right here. They store it in a code repo. So GitHub is the one on the slide, Azure DevOps being the other one from the Microsoft side, where the code is stored. And then via automate, once that's happened, then automation basically grabs that code, builds it, various automated tests as part of DevOps, pushes it to a container registry where that finished code is then stored. And then the GitHub actions will then kick off, or at least tell the Kubernetes cluster to go and fetch the latest version of this container. So the Kubernetes actually goes and grabs it, pulls it down, stands it up, done. Code is running on the cluster. So pure DevOps is pretty straightforward. But as you can see, there's a bunch of extra pieces that we would need on here. Kim, the building security folks are calling me for some reason. Would you see what they want? Thank you.
They're checking to see if your cluster's secure.
They are, yes. They're saying, are you running Kubernetes securely, sir?
I'm just trying to log in from your presentation.
That's right. Yes, that's right.
You notice that step 8 goes from GitHub Actions to the Azure Kubernetes Service, and also goes from the Azure Kubernetes Service back to the Azure Container Registry.
Yes. So what that is, the GitHub action is going to Kubernetes, and then Kubernetes, and so the action is saying to Kubernetes, hey, got a new version of my code. It's completely awesome. It's built. It's in this container registry. It's called this, and this is the version number of that thing. Go and get it. And so that then tells Kubernetes, alrighty, okie dokie, that sounds completely awesome. I will go and fetch that from that container registry. So it's a push, and then Kubernetes pulls. Back in the day, if you're familiar with how things used to do, and so containerized applications, that is the mechanism, right? There's a pull of that container, and it is then stood up. More traditional other models that don't involve containers. So in Azure Web Apps, Azure Functions, just straightforward virtual machines, the code is dropped directly onto the infrastructure. It's literally built, and the binary is pushed and deployed onto the infrastructure where they start executing. So the step of the container registry is unique to container hosted applications. And that's one of the reasons we're picking this. Kubernetes being the big boy of these, the enterprise, right? The big applications, but there are other container hosting services in Azure, all of which would pull from a container registry using this pattern. So this is next step, unique to container hosted applications. And yes.
Quick question, is it intentional to use GitHub Actions over Azure DevOps? I know you just mentioned it, but since we're kind of looking at the architecture.
Is intentional. So this slide dates from when Azure DevOps didn't have much Defender for DevOps pieces. So GitHub Actions and GitHub, you can also have Azure DevOps and build pipelines in there instead, and I'll talk about those. And in this example, we're doing GitHub. It's a little further along in terms of some of the security features, as you'll see, but DevOps also has some that you should use if DevOps is what you have instead of this bit. Does that answer your question?
It does. I just want to make sure it wasn't a recommendation or.
No, it's not a recommendation, but it is what we start with. And it is the one that has the most features at the minute.
Okay, thank you.
We'll do a compare and contrast question.
So is it like Defender for Cloud?
Defender for Cloud is one of the solutions and one of the main ones, actually. So that's an all-up product that has just a ton of features. And we're going to use a lot of the features of Defender for Cloud for the various components on the data. One of them is going to be used to talk to Azure DevOps, for example. Another one will be used to examine the images on the container registry for another. Yeah, those are both features of Defender for Cloud, yes, which is an umbrella solution. But by being an umbrella solution, like Entra, right? Just because Entra is Entra doesn't mean that you necessarily have all the features that you're using them all, that you've enabled them all, right? Defender for Cloud is another example of that. You can select it, you can have it implemented on certain services like storage accounts. I'm super paranoid about my storage account. I don't want anything bad being put on that thing. Enable Defender for Cloud. It's watching my storage account. It's checking there's no viruses uploaded to it. My infrastructure is secure, and it's watching it, and that's good. But it has a bunch of other features that if you don't choose to enable them, like the ones we'll talk about, then you're going to miss your. That's not protecting your storage account. Is protecting your infrastructure. We're trying to protect our process. So GitHub Actions and or Azure DevOps Pipelines is used, like I say, to push our code to our container registry and to our Kubernetes. So some of the other pieces that we're going to talk about that are in here, we talk about Entra. There's some extensions for the coding that developers would recommend have on their tooling. So while they're actually writing the code, they get extra feedback as to that's not good, don't do that. Don't include this, that SDK has some vulnerabilities and so on. Before they even, while they're actually writing the code, they can and should get some feedback from a security perspective that, again, they don't have to. Unless someone tells them or they know, then they're not going to just, how else would they know, right? So that's one. And then they store it in GitHub, but there are some other optional features of GitHub. What was the word? What do they want? You got it? Okay. There's some optional features of GitHub and Azure DevOps, again, that protect this security, this process that if you don't turn them on, they're not going to do anything. So we're going to show those and how they add protection to the basic DevOps pattern, right? They add security to DevOps by being turned on, frankly, and then used. Another pull requests is a standard approach for making updates to the code. Here's Microsoft Defender for Cloud, and there's I think there's a DevOps feature of Microsoft Defender for Cloud that can be used to talk to GitHub, and it will provide some protections. Again, optional feature that we'll look at. GitHub Actions, again, part of DevOps used to deploy our code to Azure Container Registry. We also have Azure Defender pointed at our container registry as well, because it also has some features for the deployed images that, again, optional, don't have to enable those. If you do enable them, then it'll give you, it will actually check for vulnerabilities in the various code components of every single image stored in the registry, all the way, even not just the code the developers wrote, but all the images that they use, the OS images they use to build all those images. And it will make you aware of those, let you know. It'll also rebuild some of those images as well automatically. So when you have a base image that the code the developer is using to build upon changes without their knowledge underneath them, because it's an OS image, right? It's an OS image underneath it. If that OS image changes, the container registry it has a way of being notified of that and can rebuild the image to get the latest versions, to get all those security patches, because that's why it would change, right? For security patches. Again, optional. There's an optional feature called Azure Policy. It's a component of all up Azure that can normally it's used for governance. You provide governance and control over what can and can't be done in your Azure estate. Can also be used to provide insight as to whether vulnerabilities in those images, for example, are being remediated, and also vulnerabilities on your AKS cluster. So it's another view into the security health of your deployed code, your images. Let's see, we have some infrastructure components that protect things. There is some logging that, again, optionally enabled from our Kubernetes once our code has been deployed. That should, it's called a service called Container Insights. It will capture all the logs off of our cluster, write them out to a service called Log Analytics as part of the Azure Monitor service, which again, optional. And then from Azure Monitor, you can monitor those from a SIEM. The Azure native SIEM is called Azure Sentinel. It can watch everything that's dropped in those logs, looking for things that seem to be going on their infrastructure that probably shouldn't. So that's the monitoring of your production running code after it's been through this whole process.
Follow question here.
Question, yes.
One, which service is not optional?
Which service?
Is not optional.
Which one?
I don't know. I'm asking which one is.
Most of them.
Okay. Looks like everything's a good thing to have. Now on 9 and 10, is there some degree of redundancy in terms of what they're both doing, the policies as well as the Defender, Microsoft Defender? Is there any kind of
Yep.
there?
There is. So Defender is going to do some analysis on some of these things, like the container registry in particular on this one. It's going to be examining the container registry. And you can choose to go into the Defender portal and see the status and health of that infrastructure. You can have it alerted on, and that's all within Defender, and that's all well and good. Azure Policy is looking at the health of the same infrastructure from the point of view of Azure Policy. And so it's going to also see the readouts of Azure Defender and whether or not there's compliance there. So by looking at Azure Policy, you see effectively the same warnings and guidance, so that there's a redundancy because whether you're in Azure Policy or in Azure Defender, you can still see some non-compliance of these container registries. And so different teams, different team is often looking at Azure Policy than Azure Defender, but those two teams will see the same information, but in two different places. So there is some redundancy in using both together, because you're still looking at the same reports from Azure Defender, if that makes sense. If that answers your question.
Yeah, sure.
Yes.
Is the same version of the Defender, or is different from the Defender we are running in the normal PCs?
So your question is it endpoint protection? So
If
none of this is endpoint protection. No, this is protecting the process. The endpoint protection would be on our Kubernetes service, potentially at the end there in production, looking for nefarious things happening on there. And Defender for Cloud doesn't have that part. There's no VMs in here, no endpoint protection, no antivirus protection here.
But the point 16, Microsoft Defender, I asking if the same version of the Microsoft Defender.
Where are we looking?
16.
I'm not seeing it for looking.
It's number 4.
I understand. Microsoft Defender scan GitHub.
I did.
Oh, this one. Oh, okay. So this is a security team who are using a service called Microsoft Defender for DevOps, which is in the Azure portal. I'll show this one a little bit later, which is configured to look at your GitHub/ADO Azure DevOps repositories, looking for vulnerabilities in the code in your repos. So this is your security team reading from the service, which is looking at your GitHub from the Azure portal. So it is still Azure Defender all up, the cloud all up service, but this is a particular feature of this service used just for GitHub and Azure DevOps. I'll show that part actually, which will make it easier to understand, I think. Again, optional feature. Don't have to have it turned on. And that's really the theme of really all of this. And actually one of the reasons that I started with when I was describing the secure infrastructure, that typically, so the AKS at the end there, we assume that is secure, but not if the quick starts are used in order to create it. There's a lot of complexity in standing up that infrastructure, a lot of optional features that should be turned on, enabled, and so forth. We're not really going to get into most of those because that's the infrastructure. We're going to assume that people deploying that infrastructure chose those optional security features because when they deployed that infrastructure, they know how important it is to make that secure. So we're going to make some assumptions that that part has been done, that the infrastructure has been secured, and these optional features that I described have been turned on. I'll touch upon them a little bit, but we have to make that assumption because that was one of the fundamental rules here, is that production infrastructure, good, that's not a problem. It's everything getting to that secured infrastructure that is the problem, for the same reason that optional features haven't been turned on. So the question then we're looking to answer here is, well, Adam, what are those optional features that you keep alluding to? And how do we turn them on? So we're just going to go through a whole bunch of those. And I'll show them as well. One of them, so in the plan phase, this one is a little bit in the weeds. It makes some assumptions that you are very familiar with AKS at this point. I'll try and summarize. There is a feature of AKS that is not turned on by default, called Microsoft Entra Workload ID. This feature at the planning phase enables authentication from code running on that deployed production cluster to use Entra identities to access other Azure resources. This is instead of the typical pattern of a connection string. If you want to read from a SQL Server database, for example, the traditional approach is, well, give the code a connection string and it'll make the connection and access the data. That's the traditional approach. The problem with that, of course, is the weakness of the connection string. Who has access to that? You have to protect it, and there's lots of patterns for protecting traditional connection strings and traditional passwords. This approach does away with the passwords. There's no password. And Entra is the service that protects that access. So security goes way up, risk goes way down, but this is a feature that's not on by default. And if you then turn it on, which again, we're making some assumptions about the fact that the infrastructure is secure, this feature doesn't secure the infrastructure any further. It enables the access from the code running on the infrastructure to do so more securely because the credentials are protected. You have a different mechanism of accessing by the credentials. And so at a high level, the way this works is there's some code. It talks to AKS, which via a service that needs to be stood up on the cluster. We'll use Entra to validate the tokens. The tokens are then sent on to the Azure service you want to read from, like SQL Database or Azure Storage or Cosmos or whatever the code needs to read from to access data, right? Whatever that needs, it can use this service and on Kubernetes should use this service instead of a more traditional connection string password type approach. Clear? So make sense? Any questions? Yes?
Is this like a managed identity or?
It is like a managed identity. You can think of it like that. Yes, it is a little more sophisticated than that. It's a little more complicated because of the fact that it's in Kubernetes. But if you're used to managed identities, which are basically system accounts that represent infrastructure, it is like a managed identity, but for an individual container. The reason that we need this, in fact, there are managed identities in Kubernetes, but then it applies to the entire cluster. And so managed identities in Kubernetes are used to make changes to other infrastructure. They're used to access the container registry to pull down images, right? But this is very specific to one workload. And there may be, of course, thousands of different workloads on the same cluster. That's why the managed identity pattern, which is a system account attached to one piece of infrastructure, one cluster in this case, doesn't give us the fidelity, doesn't give us enough protections because we can have so many different services running on one cluster. So we need this approach, which again, one feature that needs to be turned on, that's easy. And then the hard part is the developers need to use it. That's why it's in the plan phase, right? Just because it's turned on doesn't prevent developers from just using a connection string to read from their storage account. Doesn't prevent them at all. They need to use this, and the connection strings need to be removed from our DevSecOps pipeline. And there's a few places we can do that, but that's part of the planning, knowing this feature is available, turning it on in the infrastructure, and then developers writing their code to use it. Okay, that's the first one. We haven't even built any code yet.
But that's different than their log into the Active Directory.
Correct, Ray. Yes, but it is using still Active Directory Entra, right? When you said Active Directory, I knew you meant Entra because you know, I know we were right there. I read your mind. So yeah, the developer logs into Entra. That is their identity. They use that to write their code. This is after the code has been deployed to the production AKS cluster, and their code needs to read from some data store as something, right? So traditionally that'd be a connection string, a username, a password, or something like that, right? A system account. Think of a system account. If a traditional AD on-prem, you'd use an AD account, a system account, to access the database. This is like that. This is the modern approach to that in the cloud.
The question,
Yes.
will this be like the equivalent of doing pass-through authentication?
Equivalent to pass-through authentication. I guess it's including that. So it's a form of pass-through authentication, if you will, but for a system account. Yes, where the validation is all done via Entra seamlessly. So nothing, it needs to be set up and enabled, but then authentication happens without the need for credentials being stored anywhere.
What I'm seeing through the arrows is similar to what Kerberos tries to do on premise.
Mm-hmm.
So
Yep.
you have to deal connection strings when you have hybrid environments.
It's still authentication pattern, right? The key here is that Entra is the identity provider that does all of the work of authorizing the call and providing the token back to the code, which is then given to the Azure resource, which validates the token. Yes, this is valid, and then provides the service. So it's still authentication, but done on Kubernetes from code. And then, now that the developers have, all right, okay, we've got some infrastructure, it's good to go. What kinds of things do the developers need to do in addition to using that workload identity feature I just described? What other changes should they make to their traditional DevOps process? Maybe they've made them already, maybe they haven't, but there are some extensions to Visual Studio Code they should have that does some security checks on the code while they're writing it. First, so Snake is sort of a common one. It's an extension, so that's the example that we have. There are others like it, but it's a plugin to Visual Studio Code that helps the developers understand and look for vulnerabilities in their stuff, whether they're writing it or they're pulling in packages from the open source community, right? And it'll help identify those before they even compile the code. And then GitHub security code scanning is another feature that once their code's up on GitHub, then it will look for things like credentials that have been, if they're not following the practice earlier of using system accounts and they're using connection strings, they're using passwords and they're putting that in their code, it's going to look for those as well as other security weaknesses in the code that Snake would also find. Pre-commit codes, there's a pre-commit website here for this. Looks for like missing white space, malformed YAML, things that are potential security risks that are easy to miss when the code works, when all the templates work, everything works. Everything just works just fine, but due to some mistakes, some malformed, missing carriage returns in the code, things like that that don't affect the functionality of the code being written, of it being displayed, of it being built, of it being compiled, but are later potential avenues for security risks. Pre-commit can be used to check for those things and just call them out before even the developer actually commits the code to the GitHub repo. And then once the developer has fixed all the things the snake found, fixed all their typos and missing carriage returns and bad white space that the pre-commit found, they've checked their code in. So wait, they haven't checked it in. They are building it. So again, GitHub Advanced Security scanning can look for vulnerabilities in the code. And I mentioned the secret scanning capability of that. So accidentally checking in secrets is really, really common. Again, if our developers are following the practices of using workload identity, there shouldn't be any secrets to accidentally check in. That's one of the reasons for going to that approach. But in the meantime, if they haven't yet rewritten or changed their code to use that feature of AKS, once that's been turned on, then they might still be using connection strings or passwords, in which case, again, GitHub can help look for those. Some of you I know are familiar with services like Dependabot on GitHub. I was talking to some of you earlier, which looks for potential problems in dependencies the code is using. So we're past the point now of flaws in the code the developer wrote. Now we're looking at flaws in dependencies that the developer's code makes. So they're pulling in packages they didn't write, which is, of course, these days, the majority of the code in any given application that developers don't write. It's in packages that they pull in either from the open source community, usually from the open source community. And so Dependabot can help find vulnerabilities in packages that the developer has pulled in that they might not know exists. I mean, the functionality works just fine. It all looks good, no problems, but there's a vulnerability in a package that they're included that actually makes their code vulnerable as a result. So Dependabot can be used to help find those, because there's no other way. There's no way the developer would know. So as part of the deployment of the infrastructure, we're making a lot of assumptions that it's being done properly. That one of the way that would be done properly is to use infrastructure as code templates to describe that infrastructure and deploy it. And Defender for DevOps can help with that. Moonis, do you have a question?
He was asking something.
Ralph, yes, go ahead.
I was thinking maybe I could wait to the end, but so my developers are using Visual Studio
Excellent.
and Azure DevOps.
Okay,
Now,
great.
I've looked something up, and according to a couple of blogs, Dependabot can be used in Azure DevOps.
Got it. Okay.
Well, that's great. I mean, Snake or whatever it is.
I pronounce it snake, but I'm British, so don't
Okay.
how I pronounce it.
All right. Well, I mean, is that something we can use in Visual Studio, or is there something like it for Visual Studio?
I don't know about Visual Studio. I do not know. Yes, I would hope there's something like it. Again, there's other solutions other than Snake. I don't know them especially. So calling out Snake as an example, the kind of thing that you should use, and the intent is take a look at it, understand what it does, understand the value of the thing, and then look elsewhere to see if you can find anything better that you prefer, free or bought. Snake's free. Maybe there's something purchased that you can have, and up to you. It's in this case, in that particular case, it's a best practice for something like that. So maybe, I don't know, Ralph. I don't.
I can contribute a little bit to this. One of the things I've seen is that a tool like Sneak, you can add to your pull request process so that when you submit a PR, even a draft PR, then Sneak can scan whatever references you have. So if you have Docker files set up in there, it can scan for any sort of container images, or when you have a build process that has a container image, it can scan that too. So there's things you can do to help scan your code base to find things that can happen in the developer environment, in the pull request environment, or even after the fact, depending on how you want to set it up. So it just depends on the workflow you're running. You find a tool that makes sense for your developer team, because while they may choose to run on their machines, they may forget to scan or forget to look. So you got to double check them anyway. So why not just put it out there, let it run the scan on its own, and then let them know, like, hey, buddy, you just pulled a vulnerable image from who knows where. And the other thing is that when you're pulling stuff from all over the internet, you may want to, most companies will have a policy where you can't pull it from the internet. You have to pull it from a known internal repository like a ACR, or if you're running DevOps, you can run artifacts, DevOps artifacts, and then pull everything from there. So you have a chance to scan it, validate it, make sure it doesn't have anything weird in it, and then bring it in that way. So then you have a higher level of trust using things from that environment rather than pulling it from the internet.
Thanks.
So, hey, Adam,
Yes, Munish.
reminded me, what you just said reminded me of Kubernetes apps. So in
Kubernetes
Marketplace, we have a new offering called Kubernetes apps.
Oh, yeah, the apps marketplace.
And so recently I was coming across an image and it was actually RabbitMQ image. So rather than direct from the whatever the company was, you now prefer that you download it from Kubernetes apps into your ACR. So that way you can enforce the policy that only developers should only pull images from your own ACR.
Right.
And those ACRs are getting it from Kubernetes apps.
Mm-hmm. Yeah, trusted images.
Trusted images
Yes.
concept.
Yes, indeed. Yep. So I think I may or may not mention trusted images, may or may not, but I may not have included that. But yeah, you should do that. Trusted images, absolutely. And to Garo's point right there, you should also not trust what's in those container registries, because who knows, there could be what I call soup, software of unknown provenance, right? Soup in your Azure Container Registry. And so there's a feature called Defender for Containers. Its whole purpose, a feature of Defender for Containers, that goes and looks at your container registry once anything's pushed to it and looks for vulnerabilities for everything pulled in it. And Gero was saying that Snake does that from the build engines. Maybe that's another feature of that. But if you're using the Defender for Containers stack, it has some features specifically for ACRs and actually AWS as well. It can read from those. And then I talked about Azure Policy can be used to highlight those same vulnerability assessments. The assessments are going to be done by Defender for Cloud, but Azure Policy can be used to surface those up. We already spoke about that a little bit. There is another feature of Azure Container Registry called Azure Container Registry Tasks that can detect change in base images. So even though the image came from a trusted place at this point, it's, for example, an OS image, right? It's a version of Linux, and the image, and then it's a base OS image, and then you've got images on top of that, including eventually the developer's custom code. Once the image has been built and pushed to the ACR, then vulnerabilities may later come to light, not in the developer's code, but in the OS image underneath that code, and it's fixed into that container registry at this point, right? And so a pull of that will pull those vulnerabilities too. Even if later developer fixes, changes, updates anything in their code, if they haven't changed the base OS image because they don't know there's a reason to, then that vulnerability will remain. So Azure Container Registry has a feature called Registry Tasks to detect when changes in the underlying images underneath the developer's code have occurred, and it will go and fetch those and rebuild the entire stack with the new versions of those images. The code doesn't change, but the underlying images do, including vulnerabilities and vulnerability fixes. Yes.
Yeah, so with security scans, I'm used to use the Benabot and Sneak, as the guys mentioned. So in the future, if a vulnerability appears and then you need to update, you can validate, okay, let's see if it's a patch, minor, major, right, and what kind of tests I need to do, because now the components that I'm using to connect to the database has a known issue that was found after my code was deployed.
Right. So Dependabot can help with that by looking at your code stored in GitHub.
So in that part, we are talking about like the OS image.
Yes. After it's been, so in Dependabot can only look at the code whilst it's still code, right, in your repo, and it will look at it and the dependencies that your code makes. And so that's a good start. That's before anything's been built. Once it's been built and then pushed to a container registry, it's then a binary image at this point. It's a Docker image. and then Defender for containers will open that binary image and look for vulnerabilities in that. So that won't be Dependabot might not find those. Many of them are going to be in the OS image, right? Dependabot doesn't look in the OS image, doesn't know, doesn't have a clue. But Defender for containers can augment Dependabot. It's going to find some of the same things. So if people don't know to turn on Dependabot, Defender for containers can find the same issues. But at this point, after the image has been built and pushed to the registry, which is the difference, as well as the container registry task. This point right here is then looking for vulnerabilities in any SDK anywhere used in the stack of images that the code is on. So yes, you need both, right? Hopefully that's obvious. And all these, again, optional features. And this is all part of DevOps, the automatic build, the push to the container registry, the pull and deployment on the infrastructure, right? But these extra checks, this is what makes it Sec DevOps. You need them all, is the short of it. Let's see. So there's okay. I did include the trusted images part. Content trust is the feature of Azure Container Registry to ensure that, in fact, signed images. So you have the ability not just. Actually, this is actually different to what Gero was saying. This is another feature whereby the images can be signed so that you know they haven't been tampered with in between the time that that it was built and fetched. So literally, it's encrypted. It's a signed image, and then so that's a feature. And then you can, via configuration, make sure you only put images that have been signed. So that makes them so you know they've not been tampered with.
Well, wouldn't the hash do that?
Hash
the hash when the container image is built.
Yes.
Hash that's generated.
Yes.
That's how you do tamper resistance, right? So isn't this more of like kind of source, like it's been approved and signed and?
I'm not sure, Gero, the difference between the hash and this feature. This is not the hash feature. I think this is that, but more.
You sign it with a certificate. Actually, I know AKS did not always support this. So
no, this is a new feature. Yes, this is new. So yeah, not sure, Gero, the difference. But an optional feature that you should use. Don't just rely on the hash. Let's go with that. And then Ratify is a third-party product that you can use to verify artifact security deployment. So, and then the deployment pipeline should also be secured, right? So, okay, we've protected our images, they're good. We trust them because they're signed. We've ensured that we're only using trusted registries, all of that good stuff. Now we're actually going to do the deployment, which is the point where we actually grab that image at this point, right? So as part of that, there's also some best practices. Again, this is really about not securing secrets properly that you might need for authentication on the part of the pipeline. So use environments as part of GitHub or DevOps pipelines. Use branch protection rules to collaborators can't delete or force push to the branch and follow processes to protect your branches. There's an optional capability called OpenID Connect, which GitHub supports for authenticating with your Azure infrastructure. So this again uses Entra and system accounts. So it is actually similar to the approach to the workload identity I was showing you earlier, and is the way in which the GitHub action authenticates with Azure in order to tell it to do stuff, basically. There's a couple of ways of doing this. You can use secrets, you can use accounts. OpenID Connect is a newer and lower risk and optional approach that we'd recommend for your GitHub actions to do that authentication. using, again, system accounts, right? But with limited privileges. In fact, the privileges are limited to a specific GitHub repo, so it follows more of a least privilege pattern. So yes, use secrets in GitHub because those are encrypted if you need them, but not for authentication to Azure, right? Use ORDC instead. And there is actually another approach that I've called out called GitOps. So the approach that we're discussing here, the typical approach in Azure DevOps is to push. You're pushing to your AKS cluster and telling it to do stuff, telling it to go and fetch that image. There is a pull approach, GitOps. So rather than it all happening on your GitHub repo, so instead basically of using GitHub Actions to do all the work, or DevOps pipelines if you're in Azure DevOps, you can have all the work done from the cluster. So there is Argo CD is one such example, and Flux is the one that's native to Kubernetes. Those are components that get installed on the cluster. They're given configuration, which points them at your GitHub repo for where the source code is. And they will periodically reach from your cluster, check your GitHub repo, and fetch the code down and build it on the cluster, rather than having it all happening, all the build being done in GitHub. So that's why it's a pull approach. It's pulling the source code down, doing all the builds, and then pushing from the cluster to the container registry, and then pulling the image down and standing it up. So that is another approach to keeping security on your nice, secure Kubernetes cluster. It tends to be kind of complicated to do GitOps rather than the traditional push model. So for small applications or a cluster where you've only got a small number of applications, it's honestly too much overhead and work, frankly. But if you've got a large cluster and lots of teams all looking to deploy it, so it's shared, huge cluster, lots and lots of teams, then using GitOps and having them all pulling their code down onto that cluster rather than having all those teams pushing to it can be more efficient and easier to secure.
That's assuming that the code has been tested and found valid.
Yep, that's all stuff that happened at the beginning in this workflow, right? That was the snake discussion we were talking about, all of that, it's still going to be, the code's still stored in GitHub or GitOps, right? And so all those Defender-bot features we were just talking about, the Defender for Cloud features that are looking for all those vulnerability all that still happens. That's still there. The difference is the build and the push. That it's instead, let's skip that. It's a pull. Well, the code is changed, it's pulled and built on the cluster.
I have a question. So which security feature actually prevents a developer from using an untrusted image, right? So you have a situation where you have your trusted images, assigned, certified, call them golden images. What stops the developer from going out there to go pull an unsecured image, right? If you're trying to protect your entire infrastructure.
So that's going to be configuration on the Kubernetes cluster. It's going to only pull from registries that it's configured to trust and has permissions to pull from. So the developer can create some configuration that pulls a random image from somewhere else. The deployment to that cluster is going to fail at the infrastructure level because it can't see out to go and get that image. Nope, just not going to work, if that makes sense. So it's configuration of the cluster. Specifically what configuration? I don't know. I'd have to look it up.
Yeah.
Does that answer your question? Well, kind of answers your question.
Yeah, sure.
Yeah, it really, the developer is presented at the infrastructure level. They can write whatever YAML they want and list whatever they want, right? But it's actually when it comes time for the cluster to go and grab that image, that's when that's implemented. And deployment fails. Okay, let's see. This is okay. So there's the trusted. I felt sure there was a trusted registry. So maybe this might actually answer that exactly question using Azure Policy, which is there is an add-on for Kubernetes as part of Azure Policy All-Up that is deployed to the cluster that means that Azure policy specific to Kubernetes can then be implemented by this policy engine from the cluster. And so trusted registries would be that feature. Yes.
Well, but when you're talking about, I think it talks more about the layer of coordination that needs to exist between the developer leads and the infrastructure leads. So what is the policy or guidelines that they're going to be implementing to protect themselves for potential code that will come from unknown sources? Okay. So as you say, they may put whatever they want on their in the YAML in the code, and right. They're getting instructions. There's some safety controls put by the infrastructure team upon agreement, right, that hey, we're gonna only allow this sources, and then it comes and breaks.
So that would be done at the creation of the time of the infrastructure. So as part of that, the container registry would be part of that infrastructure deployment. So that, that you've securely created the AKS cluster. Okay, great. You've securely created the AKS, the ACR, which is where the images are going to be hosted. You've enabled all these features we've been talking about. You've configured it for Defender for Cloud, and you've told the developers that is where your images need to go, because that's the one that's trusted, not that one or any other one. It needs to go in there. So that is how the build pipelines need to be configured to put the images. And any other image repository, not so much, not going to work. Nothing has permissions to access that. So that's the communication to developers. Where's the image go? There. If that answers your question, that's the coordination that needs to happen. It's done at the infrastructure and communicated to the developers, because their stuff won't work unless they know.
But at the end, all these are tools that requires human factor of controlling the processes that are going to maintain the security of that operation.
Yeah, there's a lot of tools. There's a lot of collaboration between the developers and the infrastructure teams required for all of this. Yes, lots of infrastructure needs to be configured in certain ways, optional features installed, going right back to the very first one, that workload identity feature, right back to that one. Infrastructure teams turn that on, developers don't. Infrastructure teams turn it on, and they tell the developers to use it. So that is the collaboration that is required between what has traditionally been two very different silos. Yes, very important. This whole process will fail if two different silos don't work for this. It will not work. Trusted registries, okay. Let's see. Use Azure Monitor. I highlighted this on the last slide for so there's a feature, again, it's optional, called Container Insights that you can option enable on your AKS cluster specifically. And this feature will take all the logs written on the cluster. It understands Kubernetes logs, don't have to go in there, don't have to have permissions to go in there. This add-on running on the cluster will grab all those logs for you and egress them out to log analytics, where they can be sliced, diced, alerted on, and security examined, right? They're scraped out of the cluster, and they can be used to monitor the health of your code as well as track the security of it. So Key Vault is, of course, where developers should be storing the secrets that they need to have stored for access to things that they can't use the workload identity feature for. So a good example of that would be an Oracle database. Oracle database doesn't support, there's no Azure equivalent, doesn't support Entra as an authentication mechanism, has to have, you can domain join it, but there's no domains here, there's no AD. Can't use traditional domain join to access the Oracle, so we need a traditional connection string and password somewhere to access that Oracle database. That the place that should be stored is in a Key Vault, because a Key Vault is a secure place for secrets like that that can be protected. We keep everyone out. The developers do not have access to that Key Vault. Easy to ensure that, but nonetheless, even though it's a secure place that only the code has access to, and in fact, that workload identity feature is the mechanism for reading from that Key Vault to get that secret out to read the Oracle database, for example. Again, developers have no access to any of that. Even with all those things in place, you should still enable Defender for Key Vault, which will watch that key vault for anything suspicious, any suspicious reads from that thing or suspicious patterns of access to those secrets. Again, optional feature and another feature of Defender for Cloud. Let's see, and then there is another feature for APIs specifically. So if it's a common use case to use API management in front of your AKS cluster. So if some of your workloads, as well as serving up the traditional websites of some kind, are serving up APIs, again, very common. Those APIs, that code is running on your Kubernetes cluster. There is an Azure service called API management, separate component, specifically for fronting APIs to enable, it has a bunch of features. Mostly around management, enables versioning and other handy dandy things to simplify the lives of the developers, actually, if they're serving up those APIs. And one feature it also has is there's a Defender for APIs component of API management, which will protect those APIs from being called from the various ways. It examines the calls and does some checks at the time those APIs have been called. Kind of like a web application firewall for the front end of websites, if you're familiar with that, which is another security appliance that is recommended in front of internet-facing websites. So Defender for APIs is the equivalent to that, but for APIs. Because WAFs, web application firewalls on Application Gateway or Azure Front Door, they're not any good for protecting APIs. They're great at protecting websites, not APIs. So you need this service in API management to protect your APIs running on AKS. And this is true, this right here is true even if they're not on AKS, obviously, just generally speaking, but obviously, commonly AKS is used to host APIs. So if it is, we're talking about AKS, then do that. All right, demo time. I'm just going to demo some of these features, which might make some of them clearer. I'm sure everyone's had far too much PowerPoint. That was all my PowerPoint. Now I'm just going to show some of these features and then we're done. First thing is the assumptions I shared earlier about the security of the infrastructure, separate at this point from DevSecOps, right at the very beginning. That's not good.
It's very secure.
Yeah, it's so secure, no one can see it. Let me,
Or of your WAF.
let me, it's not good. Let's see. Okay. Really not, I got blank screen. That is,
The demo gods frowned upon you.
yes. Okay. Why is it not showing us PowerPoint?
Earlier, came back.
Worked when I went into. Yeah, okay. That's my, okay. So we're gonna just join Teams. We're just gonna join the Teams meeting and do it that way. Because the room is glitching on me. That's audio. Share screen. Okay, there we go. All righty. That was unnecessary, but nonetheless, here we are. All righty, on screen, just screen sharing now, we're done with PowerPoint, is a reference architecture for AKS. So I said earlier that we make some assumptions around how this infrastructure is deployed, and we're going to assume that the infrastructure follows all best practices and it's been deployed properly. And that includes a lot of optional features, and those and all of that is actually in this diagram as in terms of a best practice for how to deploy a secure Kubernetes cluster. I'm not going to spend too much time on this, just point at it as for for learning, right? There is a, it's called the AKS Landing Zone Accelerator, a secure baseline private cluster, and we have there's some bicep, there's some infrastructure as code, and some GitHub actions, in fact, that deploys the pattern you see here. So let me walk through it really quickly. It's a hub and spoke. That we have a secure private Kubernetes cluster deployed here. We have an application gateway deployed in front of it with a service called AGIC, Application Gateway Ingress Controller, which is the recommended approach for serving up websites from your AKS cluster to the public internet. Again, optional feature. In fact, optional feature. It's enabled in this pattern. Private link to a container registry you see down here. So a container registry is deployed with linked via a private network. So private link enabled container registry, private link enabled Azure Key Vault. And then there's an Azure firewall. And then this configuration is such that hub and spoke, the outbound internet access from this cluster is through that Azure firewall. So all outbound traffic goes through that Azure firewall. And because this is, there's no hybrid, there's no express route, no VPN gateway in this pattern, we have an Azure Bastion so that you can access the cluster because it's a private cluster. You can't use the Azure portal to see the state of this cluster. You need to be on the VNet of this cluster in order to do kubectl into this cluster. So again, this is how we assume that this infrastructure has been securely deployed. If anyone wanted to know, all right, well, what should that infrastructure look like? It should look like this. Okay. So assumptions then that it has been deployed. Let's see, let's just go to Defender for Cloud and a couple of things I wanted to show, which is this DevOps security piece. So I've got add environment, and you can see this is how we add both GitHub and Azure DevOps to this service. I've added both of my environments right here, and it does a lot of the static code checks that we were talking about from here. So putting this connection in, this service will then give it permission to go and read from my private repos, right? They're all hidden. It reads from those private repos and looks for all the vulnerabilities and mistakes and errors and secrets that are left in there and all the things that we'd want to know. It looks for them and it displays them right here. I won't go into too much detail because it's not a sales pitch, right? I'm not trying to sell you anything. So this is just awareness of these features that are, again, optional that you should be using if you need to enable DevSecOps the whole way. It's an optional feature, and this is how you configure both of your. So this is in particular how you use Defender for Cloud to secure your ADO repositories. GitHub has a lot of features in GitHub that you can choose to enable that do a lot of these same things. Azure DevOps does not yet, so they're here in the Azure portal, in Azure Defender for Cloud. So specifically, if you're using Azure DevOps, this is the approach for securing that. If you're in GitHub, I think, did I have that open? Well, so here's how you do it in Azure DevOps, right? So if you're in Azure DevOps, there is a task called Microsoft Security DevOps, which can be added to your build pipelines. This is an optional component that we'd recommend that your administrators add to your DevOps, to your Azure DevOps organization. It has to be an organization level add to add this component. And then each build pipeline needs to have this task in it. So this is more work, right? More work than actually GitHub, which does a lot of these things for you. But adding this task to each of your build pipelines will then do a lot of security checks as part of each of these builds. So again, optional component, a couple of steps. You need to it needs to be added to the build pipelines. Here's my super plain Jane pipeline. Add this as a task, and I think It then does a bunch of checks after that. And does all these scans. The scan lights up right here, and it checks for things that shouldn't be in there as part of this build like this. So it spots various things. So in this case, it did a scan of my infrastructure as code, found various mistakes that are put on here, and highlighted them for me. So again, extra optional feature, you need to add that to your pipeline in Azure DevOps. Let's see, I think back to my, I think I had GitHub here. Well, actually, yes, I was in GitHub. To one of my repos. For any of you who haven't shown just some of the built-in features in GitHub. Let's see, I think this one. So in my GitHub, I have under security all these native security features. These Azure DevOps doesn't have these yet. I get these. Again, I showed you how you get these from the Azure portal by pointing Defender for Cloud at my DevOps repos and in the pipelines by adding that component. GitHub has a whole bunch of features for vulnerabilities, and so these are all by default, unless they're a public repo. This dependency graph is enabled by default. If it's a public repo, private repos, you have to enable it. So these are all by default green. They're not enabled. You go in, you enable them all. So vulnerability reporting, the dependency, the depender bot, we talked about that. Some of you are familiar with it. Looking for vulnerable dependencies in your source code by reading the source code, right? So there's that one's enabled, various rules you can configure on this thing. Code scanning you can enable. So this one, for example, I haven't done it on this one, but there's a YAML file that I've got various configuration options. Again, not going to go into the details of how you configure this, but know that there's a YAML file in here. I'm going to push it straight to the main branch because I'm bad. Actually, I want to, this might even, yep. Cheating, broke all the rules, shouldn't have done that, but you saw how I pushed an item of code there in order to enable that security feature. Purposes of demonstration. So DependerBot, so that was the code scanning feature that I just set up right here. And then secret scanning, right? We talked about, so secrets that have been checked into the source code. Again, these are not enabled by default. And even you can block commits that contain secrets, as well as finding ones that have already been checked in. So these are, again, optional features in GitHub, particularly, that you should enable to lock down and protect your source code. Let's see. So Defender for Cloud there's Key Vault. It can do, oh, I need to, there's, so protections for Key Vault. We talked about that. Protection for containers, particular, we talked about that. I think I must have an old plan on this one. Yeah, I must have an old plan configured on this one because it's complaining at me. But the purpose of this is, oh, and there's, so here is the container image scanning feature. And so it is unbelievable to me how many vulnerabilities this thing found in. I've just got a few demo applications that I've built on this thing, just a couple of hello world things, a couple of examples from GitHub. And the examples don't have vulnerabilities in, the code is fine, but the images that I built, the OS images and some of the SDKs that I relied upon, or even that were dependencies, have loads of vulnerabilities in them that were identified by this. Look at this, just a huge Debian security updates. So lots and lots of OS flaws in here. And look, there's 377 of them in 10 images in this container registry. I only got 10, and they're all demo images. So it was quite surprising to me just how many this thing found by scanning my container registry. So again, this is an optional feature that we talked about. There's a lot, including Python. See, it finds vulnerabilities in a Python package being used there, and so on and so on. There are just hundreds of them. Lots.
Question is,
Question, yes. Yeah.
Is there critical too on that list? Like, is it go, because usually it's critical then high.
This goes from high to low.
Ah.
There's no critical. This is a vulnerability. In this particular one, it's high. It was published back in 22. It's patchable. There's some documentation on it. This is part of Debian. So this is an OS image. Way, way below all my code. I have, as a developer, not a clue. In fact, as someone who pulled down some examples from GitHub and built them, even less of a clue. Didn't even write the code that is on the top of this image. I grabbed it all as an example from GitHub. And yet there's all these vulnerabilities in underlying packages that are on the images that I used. Those need to be fixed. Oh, this one's MariaDB. Don't know why MariaDB is on this particular image. I didn't put it on there, don't know. But anyway, my point is, I have no idea, right? But this thing found a whole lot of a lot of flaws in stuff that my nice secure, because I have a Kubernetes cluster that I showed that diagram. My Kubernetes cluster that runs all of this stuff. This is the container registry that's part of that deployment. So it is secure as anything. It is like a rock. My Kubernetes cluster, it is great. So I'm pulling down these vulnerable images onto my nice secure Kubernetes cluster. And the only reason I know is because I've got Defender for Cloud pointing at my ACL. Okay, let's see. What are things? So container registry is probably one of the bigger ones. We have this API security feature in API management. I do have an API management in here somewhere, I think, with that feature enabled. Yep, there it is. And so this is an API management service, a totally separate feature in Azure with a Defender for Cloud feature as well for this service. So again, I just showed it as a container registry and I pointed Defender for Cloud at it and it found all these problems. This is a different service, API management, that serves up APIs. It's got a whole UI for viewing my, okay, no, that's not. So I've got a whole UI for viewing my APIs right here, and I can pull them in, I can stand them up, and I've got a pet store, and there's a whole ton of features of this thing. My purpose today is not to show you all those features. It's serving up all these APIs for pets, because this is a pet store. I can create, update pets, update list pets, and all kinds of stuff like that. And that's all completely benign. And then I have Defender for Cloud installed in this. So the idea is that this pet store, the APIs running that pet store, are running on Kubernetes. I mean, they don't have to be running on Kubernetes. They can be running on anything in Azure that they want, or even on-prem, on VMs if I want. Purpose here of saying is that there is a Defender for Cloud feature for API management that is specifically designed for looking for problems in your APIs. So it has a few suggestions here, like this one doesn't allow encryption, for example, and so there's various features. These APIs are pretty simple, but there are others that might be vulnerable to SQL injection attacks, all kinds of things that as a developer I might not know. This service helps me find those. The other things I was going to show. So in my Kubernetes cluster here, which is deployed properly, it's a private cluster. It's all locked down. This too has Defender for Cloud configured for it. So there's various. So this one has some Kubernetes specific knowledge and recommendations from a security perspective that is telling me that I should implement in my infrastructure. particularly ports, and there's various things. There's 17 different things. I'll just iterate through them. So container images should be deployed from trusted registries only, for example. So it spotted the fact that I'm not pulling an image here on this cluster from a registry I marked as trusted. That's an audit. There's certain ports. So some of these are infrastructure. Yeah, so there's others are recommendations more to do with performance, like this particular one, but you get the idea. That one, privilege escalation, don't do that, and so on. You get the idea. This is specific to Kubernetes at this point. There's also, I think I'm not going to be able to see it on this particular cluster. It's a private cluster, but there is some monitoring recommendations. I'm not set up to demo that because my cluster is private, which means that from the Azure portal, I can't see. I've locked myself out of actually showing you one of these features because it's a private cluster. And so, yeah. Okay, what else did I forget? I think those are the main ones I was going to show. Yes. Okay, so most of them related to Defender for Cloud. There's nothing. I'm going to look at my picture, see if there's anything I meant to show that I've forgotten. I showed GitHub. I showed the options you can have for GitHub. You have some questions around, can we switch our ADO? I showed Azure DevOps, showed Defender. This was from the Azure portal. Let's see. I showed the container registry. Oh, well, Azure policy has its own section, right? And so I showed it on the cluster right there. So Azure policy is an all-up service right here with a bunch of definitions in it. And then these are all of the built-in policy definitions, which come out of the box, which again, it's optional, but optionally, you should apply these to your Azure subscriptions so that it can audit them for compliance to these guidelines. Like you should actually have Defender for containers should be enabled. That would be a good idea because it won't tell you all this stuff unless you do. And then it found some things here for like vulnerability assessment. Yeah, I mean, you get the idea. You can read some of the example policies that should be container. So there we go. Container registry. So this one, we want to assign this definition at a scope to, for example, a subscription. This is my subscription. That's like a resource group, and apply this and then monitor for non-compliance, right? So that's this is, again, from a governance perspective. We can see compliance under the compliance section. How many of these Azure policies that I've applied, like this Defender for Cloud one right here, how much of my infrastructure actually complies with this policy so that I can monitor it from all up. So rather than going to each individual service, this is another view into the same information. I'm looking at the same thing from a different perspective, from a different Azure service. I can do different things with Azure policy as well. But yeah, compliance all up, irrespective of security, is another view that we should be using. Talked about Kubernetes, talked about Key Vault. Okay, I think. And I couldn't show container insights right here because my cluster is private and I've locked myself out. But there is container insights deployed to my cluster. I was actually going to show, so I won't show that. Okay, questions? Thoughts?
Complicated.
Yes, it is. There's a lot to it, right? There is a lot to it. A lot of, you saw just a ton of optional features. I mean, there's one thing I can leave you with here, right? All this infrastructure and enabling DevOps, that's what we talked about at the beginning, can be done very easily with a few, you can stand that up with, honestly, quick starts. You can get the documentation, you can get the infrastructure up. You don't need to enable all those features in Azure DevOps, all those components in Defender for Cloud. It's not on by default, don't have to have it on. Just stand up the container registry, stand up the cluster, get GitHub going, just push your code to it, and then create a GitHub action to build it, push it to container registry, have Kubernetes stand it up, Done. Really easy. Honestly, really easy. Skipping a whole ton of optional features which close a whole lot of security loops. And that's really honestly the message. There's a lot of areas of risk that you skip by not understanding those risks and enabling these optional features. In order to do it.
But only the things that affected Visual Studio and Visual Studio Code would be noticed by the developer. The rest of it is all upstream from that.
Actually, that's, well, the developer would also notice the vulnerabilities found in GitHub because it would call out, because when they try and do their builds, they would fail because it finds secrets in the code. Nope, not building that. And developers, oh, why did my build fail? Oh, because I put in a secret into my code. Oopsie. All right, need to fix that. So they would see some things further upstream caught by, and Dependabot, there's a vulnerability in this SDK I'm using. Okay, that's not good. Someone would tell the developer, fix your junk. Why is that? Dependabot finding there's a vulnerability in that stuff. So again, the developer would be told that. That would be in a report. And then later, the developer should look at Defender for Cloud at the vulnerabilities on their images, right? Someone needs to look at that and eventually tell the developer to use a newer version of their image. So that's the developer's going to hear about these problems further down the stream, further downstream, all the way to they've got their code's good. They've pushed it. There's no dependencies. It builds correctly. It pushes to the container registry. It's clean. There's no vulnerabilities. It stands up on the AKS cluster. It's running in production. It's an API. They've got API management in front of it. And then API management finds a vulnerability in the way they've implemented their API that got through everything else. And finally, API management says, yeah, you've not enabled this feature. There's a security SQL injection vulnerability possibility on the way you've designed this API. And then the developer, all right, fine. I need to correct that as well. So the developer will hear about it.
They'll hear about it.
They'll hear about it on all those steps eventually, but you're right. The ones they will see first are when they're writing their code from Snake. And then second, when they try and push the code and it doesn't build. Once it's built, then, okay, they can relax and they might get a little period of time before they hear about the next thing they need to fix. Yes. Yep. That is the way of it. Right. Any other questions? Yes, Ralph.
I like all of this, but I'm worried about breaking the budget. So
Breaking the budget. Oh, how much does this cost?
exactly.
Oh, I
Can
don't
you put a
actually.
price on a good night of sleep?
Yeah,
That's a good question.
yeah. That's a good question. I actually don't know how much Defender for Cloud costs. I actually don't know.
It's billed per hour, like a certain amount per hour per managed resource.
It varies. It varies, right? So Defender for Cloud is an umbrella. It has a ton of optional stuff. I think when I showed it, you saw all the different things. It can monitor storage accounts and API and all the rest of it. Each of those little pieces is, I think, billed differently. So like VMs, it's per VM, right? So there's a fixed price per VM and other things. I don't know. I think container registry might be per gig. I'm not sure of images that it scans, something like that. So it varies. You'll have to use Azure Calculator to figure it out. I don't.
Are any of these components, can you schedule them and, save money that way, or they just, you either have them on or off?
You're either enabling them or you're not. Yeah, and it's by count of resource usually. So I think the answer to your question on that one, with virtual machines, you can schedule it and save money because you're only paying for it while it's running. If you've got a vulnerability assessment, you pay for that virtual machine whether it's running or not in terms of Defender for Cloud, for example. Yeah, I don't know if any of them are per hour. I don't think so. But.
Yeah, so Defender for Cloud, they're multi-flavor, like Adam was saying. And there's a free cloud foundational feature that come with it. But in terms of money and cost, it's depend on each of the flavor that you're subscribed to. And typically there's an Azure calculator that we can leverage to get an approximate, but that cost is approximation of what you put in. But if you have an enterprise agreement like a Mac, you have discount. So check with your, your account team that work with you. And I've seen customer have 25%, 30%, it depends on, what is tailored to your organization and how much the consumption that you are committed to consume Azure, and you get a lot of discount that way. So I wouldn't worry about too much the cost. It's about, is that the right thing for you, a solution right fits your need, and then we can work out the detail later. But
Yeah, I'm looking it up. A lot of them are per hour. I was wrong about that. Look at that.
But don't get me wrong, it's just the tip of the iceberg because you have to have power to maintain these operations.
The eyes on glass.
So,
Yeah, you can change this to hour to month, and then I think it's not that much of a cost. Like if I'm looking for containers, it's like $6 per container per week or.
Like that, if I change them
Yeah.
up, pricing per month, and
Yeah,
then it's, oh yeah, there we go. There's the pricing per month. Look at that. What a bargain. I've no idea. I've never looked.
You're paying more than that for your database.
Not a sales guy.
But I think what's important is the human factor of it, right? So you could probably do all this stuff yourself.
Oh, yeah.
And not pay this bill, but your person hours to do that implementation, your compute cost of running an implementation, at some point, it's gonna exceed this. And so here it is already baked in and you've got a lot of features. You see, does this work for you? If not, you can turn those features off and bring some other tool in that makes sense and try that. So you got the power.
So basically, you leveraging the service to save the human labor. I'll give you an example, like Azure Arc, the extended security update. A lot of our customers use this because instead of having 5 or 10 engineer patching thousands of server in the org, they reduced down to what, $75 a month for server versus how much do you pay per person, a full-time person a month is salary sitting patching your server. So that's the scale of economy and cost saving right there. But is that mean that they're going to reduce in laying people off or people losing job? Probably, yes. But the heavy lifting is done smart, and businesses are in the business to make money, not to lose money. So if you can evolve and save a couple of thousand, it's a choice. It's a delicate dance between human labor versus how can I optimize and direct my labor to do something else more productive instead of just sitting patching server.
Well, the money that you invest in here is not that, I don't think is that much into the labor because you're trying to reduce risk into your operations.
That's exactly it. It's lowering risk.
When I mentioned a moment ago the tip of the iceberg, for me, I'm in infrastructure, and when I work with developers, a lot of times they just sell the idea to the business. Everything is possible. The resources are unlimited, but the business will not understand that unlimited means every type of consumption that you choose, every wish that you have that you put as a feature request becomes an operational request.
There's a cost for that.
To bring them into operation. So when they start saying, oh, okay, well, let's start turning on things, then you have all these non-functional needs of bringing it into operation, monitoring, patching, curating it, bringing it integration with all the aspects of IT. That means just bringing this single application. And when you have multiple streams of development start happening, and maybe not all the skills are in place for understanding all the different learning curve, all these features comes in place, it becomes more of not that much of a decision if we're going to choose or not to use these things. It's like being, as you mentioned over there, the first part is the planning of what we want to bring into our operation and make decisions that can reduce these necessities in one way or another. Sometimes you can reduce some of these vulnerabilities, segmenting your network or segmenting your operation. So you're not expanding your footprint on your resources because maybe you don't have the manpower to manage the code or manage all these registers. like you have certain components that you're not accessible from the internet because you need to be in a specific
Yeah.
networks of operation.
Yeah.
So you start containerizing some of these vulnerabilities. Maybe you don't go into investing into this operation, but you're indirectly controlling that risk, making decisions on your design.
So yeah, from a planning perspective, then this is the diagram that you should use to encompass all of that and sell this to the business as terms of, all right, you can, resources not unlimited, but this is how we do it properly. And in conjunction with this pattern, right, the secured infrastructure that I was showing at the beginning, some of the best practices for standing up the infrastructure, the Kubernetes parts itself, doing that all properly as well. It's again all about lowering risk. Eunice.
Yeah. So I was reading about the container pricing for the Defenders. So it's not by the pods. So I just wanted to share, like, so let's say I have a Kubernetes cluster with a, like normal size 4-core nodes, and I just have one node. And let's say I have 20 pods running, then that pricing of $6.86, right? That is only going to price it by vCore, which means 4. So I have 4 vCores on my node. And so now you're gonna, like charge me that $24.
Okay, so the vCores is the number of cores on my node of my AKS cluster.
Yes.
Okay.
Not by the containers or the pods,
Yeah, you pack a
which
bunch
is
of containers on.
significant less pricing.
It's cheap.
Yeah. If one node or the 10 nodes, right? If somebody's running 100 nodes, yes, that they will.
That would add up.
definitely-
Giant Kubernetes cluster, that'd be a few bucks for sure. Yeah, but yeah.
Pay more than any computer already.
Mm, oh,
So it's just a premium, a little bit.
Yeah.
Not even a premium, actually. It's just a little bit on top. I think, so for me, the real key is like reading about all the best practices takes a long time to understand, like, okay, read the documentation and say, did I actually understand? One, did I understand what the documentation said that I need to do? Two, is the documentation actually up to date and correct? Which sometimes is not.
nope.
So I don't know. I can't read that much. I don't have that much time to sit there and go service by service and figure out exactly what it is. So I say, okay,
Yeah.
that's this value here.
Yeah, you can delegate all of those best practices to this thing. And
Right.
it'll say, yeah, don't use that old junk. There's an old version of this you're using. It calls it all out.
But the real sneaky thing is that's the important thing is that you do this in your non-prod as well, so that you test all these things in your non-production before you go to production. So as your development team is deploying stuff in there, they need to see that they're under the same constraints in development that they're going to be in production. Because otherwise they go to production and they're like, well, why doesn't this work? Like, well, because it's the old version and it's wrong. I didn't know that. Well, you got to throw it in the non-prod. But everyone tries to save money by turning off all this. Oh, maybe we don't
Out,
run in
Dev.
this environment. Nickel that, but then you lose that first time you have a problem. You've blown out all the budget you spend on Defender on a meeting to get everyone together to figure out what's wrong. You just lost it right there.
Any other comments, observations?
And this is more to continuous development processes. You would run this stuff all the time.
Yes.
We had scheduled releases. So I think that we could have done everything through the GitHub stuff all the time. But when we get closer to the release, then we could say, okay, now let's turn on the rest of it and see what else there is.
Well, that's a waterfall approach.
Yes.
Right. So yeah, you're going to have really long steps between your waterfall.
Well, our releases were based on the release of ASCE and certain other government, publications. So.
Okay. Yeah, that's not DevOps. That's
Shift right.
DevOps
Shift right.
shift right. Yes. Yes.
DevOps was starting with the coding and development, moving to all that other stuff was DevOps, but.
Well, no, DevOps would be continuous integration, CI/CD as well, right? So it's not waterfall long approaches. DevOps is rapidly iterating and deploying and changing.
As people made changes or added features or did whatever the government said.
Those get pushed.
Pardon me?
Do those get pushed? They get built, pushed to
They get
environment,
built,
and they get
tested and pushed and then a development, a production version is created, but it's not released yet.
and that's the difference. So DevOps, right? It's released.
Yeah.
It's out there. So
You're gonna do that, then you gotta do it all.
yeah. Yep, exactly. All of this precisely. Yes. Yes.
Open question for the developers. How much is expected the infrastructure team will understand what you guys are expecting on the collaboration efforts for bringing this into the pipeline? Because who will own this? It's expected that you say at the beginning that there was a correct infrastructure implementation.
Yes.
Infrastructure, a lot of times they're not developers.
Nope.
And they will not have an understanding of how it will look like, as you say, when you are using Visual Studio and then you come and then see certain components that are bringing you alerts, what you want to do, how you gonna remediate, how you gonna curate all these containers that are coming in place. What's the effort that you guys see on a day-to-day basis into balancing who's owning that responsibility on maintaining this ecosystem?
Well, silos, right, are the traditional approach. There would be the development team who follow Ray's waterfall approach, build the release. It's one gigantic pile of code on some file share somewhere. And then it's like, all right, good to go. Infrastructure, good luck. Have fun. Send us the logs when it breaks, right? And it's just separate silo in infrastructure. Oh, what is the junk they've given us this time? Some crummy Word document on how to install it. Okay, fine. Yeah, it's up. Okay, whatever. Or it's not. And then, oh, it's not up. Well, send us the logs. And that was the silos of old. In this modern world, those silos, that does not work. Now, again, the infrastructure don't need to understand how to write code, but they do need to understand things they didn't have to necessarily before, like that workload identity piece. That's an infrastructure component. It needs to be enabled by the infrastructure team. The developers don't enable that, but the developers do need to use that. And there's other similar features enabled by the infrastructure team that they need to know that the code uses, that the developers then need to implement. The infrastructure team don't need to know how or what the developers need to do in order to use that feature, but they do need to understand that that feature's there, how it's configured, and why it should be there as part of that. So there needs to be more understanding of the DevOps lifecycle of the world of the developers than there used to be in the past. And similarly, the developers need to know a lot more about the infrastructure, in particular, than they used to in the past. They need to know and understand, okay, particularly in the world of the cloud, this is what my code is going to be running on. And these are the features that I need to use in order to do it. So like managed identity being one of them. And that's a classic one. Traditionally, there would be a connection string. The developers would have to find that, and there'd be the infrastructure team would have to plug the right one in when it gets deployed to production. The developers would never see it, right? That's the classic silos. In the modern world, there's more modern approaches that are infrastructure enabled that developers need to know how to use. Developers need to understand that. They need to know that workload identity. They need to know how Entra works, how that feature on Kubernetes works. They need to read the docs and they need to write the code. They need to use the SDKs. And that's a very infrastructure-like component. There's lots of other infrastructure. So Key Vault, that is a piece of infrastructure. That's not some automated black box that just happens and does things. The development team need to know that's the best practice. Infrastructure team need to know that's the best practice. Infrastructure team need to create it, and developers need to use it. So there's increased learning on both silos, on both sides. And in the middle, there's usually a DevOps area of focus or team that sort of cross both and own the GitHub or Azure DevOps side of things.
What practices you think, your experience you have being able to bring into the communication to try to get these teams to understand each other? I, for example, tried to, for this year, work with the developers into trying to develop some protocol to understand the bill of materials, what they're expecting to develop, what is the equivalent on an infrastructure side. But it collapses because it's a very difficult mental process of understanding of something that we don't have any idea about how we look at the end. So you're trying to formalize a bill of material as you start seeing your testing, your development process, and then kind of have an idea of what eventually will become production. But it's a very difficult process and painful in regards to try to maintain and procure, which at the end it becomes, hey, you know what, here's the key, just break it. There's no time for.
Yeah, I don't have time to learn this. Can you just do it? Yeah, and that's the traditional silos of yore, which is, yeah, change is hard. I'll just say change is hard, right? Success is in learning and collaborating, and the enemy is in traditional silos. How to defeat that? Yeah.
I think that has to be a
Just like-
management issue.
Interesting. I think Microsoft has this cloud adoption framework that exists out there that shows you how to really set up your teams, right? Helping them understand what that shared responsibility model really looks like, which we're doing what, at what point in time. I think that might be potentially useful for you. Just kind of think about things strategically, as well as you also have this whole well-architected framework. So a few frameworks out there that you could potentially leverage to kind of guide your thinking around that. Yeah, I think as well.
There's another angle too that, like around platform engineering, and there's a concept that has been floating around more called internal developer platform, which talks a lot about the problems you're saying, like where as your cloud environment becomes more complicated, you can't learn everything, right? You've got infrastructure people who are really good at infrastructure. You've got developers who are really good at writing code. You've got maybe some DevOps type people who are great at the processes and things between. But like exactly what you said, how do they communicate with each other? And so part of it is the platform engineering, which is building the tools and having that be the way that you communicate across teams. So infrastructure team creates patterns of deployment based on like your platform and the pieces you want, and say, okay, do you need a small, medium, or large? Like all your applications should follow like similar patterns and pathways and things that you see. Otherwise, you're going to have a hot mess on your hands, right? So you're going to see the same things over and over again. If you say, well, okay, it looks like this flavor, so I'm going to make a pattern for this flavor. And if you want it, here's the 6 levers you can pull and knobs you can adjust to change the size of things. And then say, here's my documented approach. So your infrastructure team can have those templates. Your development team now can understand it because they don't have to understand AKS. They just have to know, okay, here's the 6 things I can adjust. Here's the levels I can adjust them to. Here's what it means. Now I've got a way to talk between each other. And your security can come in and say, well, here's what you need to make sure you do. And your policies can come in, your development team understands. So you have it takes more work up front to build up to that, but it's like more complicated environments. We're seeing that is the thing that people are more coming into.
I noticed that online, Shyam has a question. You got your hand raised. You want to come off mute, Shyam? Go ahead.
Am I audible? Hi. Hello.
Yep, we can hear you.
Yeah. If we have time, like I think there is a question on how developers can manage the cloud, right? If there is a time at the end, I can give some insights from my experience from my previous role. Yeah.
Okay, what do you want to share, Sam?
Yeah. So so basically with this cloud migration, right? Say if we have on-premise and we are moving to the cloud. So basically it allows a lot of like flexibility and like we can use DevOps and things. So earlier, like you were saying, right, more things are in a waterfall model. Say like you need some resource in the infra side, right, to deploy application. You have to create a ticket, then somebody from the infrastructure side, they will get things ready like a virtual machine or create the application server, everything. So right now with the cloud, right? So we have the infrastructure as code, right? Like Terraform or CloudFormation, like Bicep. So many things are there. So we can easily create all the things we need. So like basically for us, like pretty much in our organization, we are given the flexibility to determine what are the things we need, resources we need in the cloud for our applications, and then get it reviewed by architecture team. But we were given the flexibility to create everything ourselves. So we don't have to like depend on any centralized team on everything. So we can even so we written all the scripts like in the Terraform to create like say AKS cluster or like container services or like static web apps like in Azure. So we did everything. And like if there is some edge case like some firewall access required or something, only for those things we have to work with a centralized team, right? So who manages that on a centralized level. So yeah, pretty much we had the flexibility to do all that. So yeah, so some knowledge of the cloud, like it will be maybe not everyone, but at least few people in the team, if they can, developers can work on this piece and take care of that. And mostly it's like a one-time thing. Like if we get it set up initially, then we set it up like almost 1.5 years back, and it's been working fine until we migrate to some other thing or not. But yeah, that just wanted to share this. Or if you have any other questions.
Interesting. Yeah, thank you for sharing, Shyam. So how much of this DevSecOps were you able to incorporate into your self-serve on-demand approach you described?
Yeah, so we did the depend about what I mentioned, the depend about alerts, we enabled it, especially with the NPM, we have a lot of packages, right? So we don't know what is pulling what library, and like it gets frequently updated, everything's open source. So we did that. We did the code QL scanning. We had like Coverity also, Coverity 45 for some applications. Yeah, we did all those scannings and everything.
Okay.
Yeah.
So you did it on the developer side. So like Ray was saying, the bit that you can normally see, which is in your development environment, and then in your source code repo, in this case, GitHub, you enabled the various tools and services. What about further downstream into the infrastructure, monitoring the packages on the ACR, that side of things?
You know, you're not plugged in. Right? Yeah. So
Yeah. Over there, like it's mostly like if we saw that we didn't really matter much because we don't communicate to like public internet or something. Like it's mostly
okay, internal only.
It's
right.
all in VNet in Azure and it's deployed there. So
right.
yeah, but yeah, it was reviewed by security team. Like any is it all protected behind like Azure AD, like Active Directory, like all the API requests like that are going. Should check for the token, right? Valid token. So that level of security was there. Yeah, but yeah, we did take care of the initial during the build process itself. Check for security things and coding best practices, all those things.
Okay.
Yeah.
Well, okay. Well, good. I mean, one thing I'll share that I've seen, right, is just because your infrastructure isn't internet facing doesn't mean that you are not at risk, right? That's what I was sharing earlier. The assumption typically is that the infrastructure is good. We've done that properly. The risk is on everything from the identities of the developers through all of the processes that get your code onto that infrastructure, because if that code on that infrastructure has vulnerabilities snuck into it somehow, or they're able to be leveraged, right, then even though your application isn't internet facing, it can still get to the internet usually, and therefore nefarious code you didn't know was there can read your data that's on your system that isn't internet facing and egress it out to the internet without your knowledge. So you have risks there. It's still part of this. So hopefully showing this today illustrates that. So
yeah,
something to consider, right?
Correct. Yes.
Yeah, thanks for your input. All right. I mean, we're quite late. If no more other questions, then we'll call it for another month. Thanks everyone for the discussion. I hope this was interesting. Hope to see you all again next year.
Good night.